We're going to take time to go back over everything that's going to be on your upcoming quiz. So to begin with, we looked at adding, subtracting, and multiplying polynomials. So for the first one, we're subtracting. And the important part about subtracting is remembering that this is a negative 1 that we have to distribute into that parentheses. So the first parentheses stays the same. And then all the signs in my second parentheses are going to change. So I have a negative x squared, a positive 5x, and a negative 7. Then I'm just going to go through and combine my like terms, starting with my biggest exponents. I start with my 2x cubed, and there aren't any other x cubed, so I'm just going to write that as part of my answer. Then I'll look at the negative 4x squared, and I have a negative x squared. So negative 4 and negative 1 is going to give me a negative 5x squared. Then we've got the x's. So I got an x and a 5x, which is going to give me a positive 6x. And then I've got my constants, negative 4 and negative 7, which is going to give me negative 11. For number 2, I'm adding, but before I can add, I've got to distribute into my parentheses. So the first one is going to become 3x squared minus 15x plus 4 minus 4x squared. And because I have parentheses, or adding, I don't need my parentheses. All right, then I'm going to combine my like terms, starting with the highest exponent. So I've got 3x squared negative 4x squared, which is going to give me a negative x squared. And then negative 15x is by itself. And then the positive 4 is by itself. And then for number 3, we've got multiplying. So for multiplying, we're going to either FOIL or box. So we'll do both, just so everybody can see which way they want to use. So to FOIL, I'm going to take each of these terms in my first parentheses and multiply them by everything in my second parentheses. So I got to do x times 2x squared, which is 2x cubed, x times x, which is x squared, and then x times negative 3, which is negative 3x. Then I've got to do my negative 5. Negative 5 times 2x squared is negative 10x squared. Negative 5 times x is negative 5x. And then negative 5 times negative 3 is positive 15. Then I'm going to do my like terms, which are usually going to be close by and in the middle somewhere. So I've got an x squared and a 10x squared and a negative 3x and a negative 5x. So I've got 2x cubed and then x squared and negative 10x squared gives me negative 9x squared. Negative 3x and negative 5x is negative 8x, and then my plus 15. The other option is the box method, which I'm going to have a 2 by 3 box. It doesn't matter which way you put your 2 and your 3. So I've got to have enough for the binomial and the trinomial. So because I put the 3 going across side to side, I'm going to have to put my trinomial on top. And then going down the side, I have my x and negative 5. So then x times 2x squared is 2x cubed. X times x is x squared. X times negative 3 is negative 3x. Negative 5 times 2x squared is negative 10x squared. Negative 5 times x is negative 5x. And negative 5 times negative 3 is 15. If you have any like terms, you don't always, but if you do, they're going to be diagonal. So I have two sets here that I'm going to add. So I'm going to bring down the 2x cubed, and then negative 10x squared and x squared is negative 9x squared. Negative 5x and negative 3x is negative 8x, and then a positive 15, which is what we got before when we FOILed. Then we've looked at dividing polynomials, and the first way we divided was long division, which works every time, and you don't have to change anything. Just make sure that your exponents are in descending order and that you're not skipping any exponents. So in this case, I've got 3, 2, 1, and then 0, no variable, so I'm good to go. So on the outside, I've got x plus 3. And then on the inside, 2x cubed plus 4x squared minus x plus 1. And we work with this x out here. So x times what gives me 2x cubed? Well, x times 2x squared. And now I take my 2x squared and multiply it by everything I'm dividing by. So 2x squared times x is 2x cubed. And then 2x squared times 3 is 6x squared. And we subtract. So 2x cubes cancel. 4 minus 6 is a negative 2x squared, and then bring down my next term. X times what gives me negative 2x squared, and so x times negative 2x. And take my negative 2x times x plus 3, so negative 2x times x is negative 2x squared. Negative 2x times 3 is negative 6x. And then a negative becomes a positive, so I have negative 1x plus 6x 5x, and then bring down my plus 1, and then x times 5 gives me 5x. So 5 times x is 5x, 5 times 3 is 15. Subtract, those cancel, 1 minus 15 is negative 14. So then I write my answer with whatever's on top of my division bar. So 2x squared minus 2x plus 5 minus 14 over x plus 3. And then we looked at synthetic division, which is a little different, but remember in synthetic division you need to have a 1x here, or just a variable, no coefficient other than 1. Right? If you have a different coefficient, you'd have to divide, and I think long division would be the better way to go. So I have x minus 2, so I'm going to put the opposite of that, so a positive 2 in my box. Right? And then here, again, you have to make sure you're not skipping any, which we skipped 2 different ones. We have an x to the 4th, then x squared, then no x. So I'm missing my x cubed and my x to the 1st power. So those are going to be my placeholders. So my coefficient for the x to the 4th is 1, and then I have a placeholder for cubed. Then for squared is negative 1, a placeholder for the 1st power, and then a positive 1 for my constant. Draw my 2 bars, make my little T, and then bring down the first number. Now 1 times 2 is 2, and we add, 0 plus 2 is 2. 2 times 2 is 4, we add, negative 1 plus 4 is 3. 3 times 2 is 6, 0 plus 6 is 6, and then 6 times 2 is 12. 1 plus 12 is 13. And then remember, I started with an x to the 4th, so that means here I'm going to have an x cubed. So I have 1x cubed, or just x cubed, plus a 2x squared, plus a 3x, plus 6, and then my remainder is going to be 13 over whatever I divided by, x minus 2. And we're done.